This is a continuation of the part one of bind structures. So now we have these structures here, and we want to figure out how many carbons and how many hydrogens there are. So feel free to pause at any moment and try to do this on your own. This is really good practice. So let's look at the first structure. Let's look at our carbons first. So we said that each endpoint corresponds to carbon. So let's start figuring them out. 1, 2, 3, 4, 5, 6. We have 1, 2, 3, 4, 5, 6. And then the way we do our hydrogens is that we just want to figure out that this carbon has already one bond. It needs 3 more bonds. Each carbon that is in a corner like this, that's a CH2. So it just needs 2 hydrogens. Why? Because this is a carbon with 2 bonds already. Each bond has 2 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. Octet fulfilled. This has 2 ends. Each carbon has 1 bond next to it. So this is going to be 3. 3 hydrogens. And that is how you do your carbons and your hydrogens. Let's look at 2. Alright, so for our structure 2, let's circle all of our carbons. Each end is a carbon, indeed. So we have 6 of them there. 7, 8, 9, 10, 11, 12. We have 12 carbons. But let's do our hydrogens. See how many hydrogens we have. Each time there is a carbon at an end, we know it's going to need 3 hydrogens because of the octet rule. So each end is going to have 3 hydrogens. Okay. That is done. But now let's look at inside the structure itself. We know that our carbons are right there. We circle them. So let's take this one, for example. If we were to count the bonds that this carbon has, it has 1, 2, 3, 4. It has 4 valence electrons. It doesn't need any more. It doesn't want any more. If it had more, it'll violate the octet. So can we put a hydrogen on that carbon? No. What about this one? The same. It has 4. Look, 1, 2, 3, 4. No hydrogen. Same. 1, 2, 3, 4. Same with this one. Same with this one. Same with this one. So all those carbons in the center need no hydrogen. And a little trick that you can have and you can remember is just that this carbon has another bond. So let me highlight the bond. Bond, skip, bond, skip, bond. Whenever you see a cyclic structure with that, it's technically called a benzene. Well, the cyclic structure itself with the bonds. Those carbons are not going to have any hydrogens. For the most part. Alright, so let's look at this next one. Let's locate all of our carbons. So we have a carbon here, one here, one here, here. Alright, so we have 6 carbons. And now let's look at our hydrogens. What did we say about a carbon? Well, in this case, this carbon, however, has 1, 2, 3, 4, 5, 6. It still needs 1 hydrogen. This means that this one's exactly the same. This one will need 1 hydrogen. This one, this carbon down here only has 2 bonds. So it'll need 2 hydrogens. This carbon will, it's the same as the one previously. As is this one. What about this carbon down here? Carbon double bond to a oxygen. Forget the lone pairs. It already has 4 valence electrons. So 1, 2, 3, 4, 5, 6, 7, 8. So that's happy. No more hydrogens. Let's take a look at this structure. This is a bicycle structure. Each corner will represent a carbon atom. That rule doesn't change. So let's count the carbons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So this is the same if we were to draw it as a kind of little messy structure. C. I'm just completing the lines, and wherever there's a circle, I'm just putting the carbon there. I'll put this, and then we have another carbon that comes up, kind of like here, like that. Let's count them. 1, 2, 3, 4, 5, 6, and 7 carbons. Perfect. Now if I were to just add the hydrogens, all that I gotta do really is put my hydrogens. We know that a carbon this carbon has 2 bonds, so I just need 2 more. This one has, look at this, 1, 2, 3, 4, 5, 6. Just need 1 more. How many does this one have? 1, 2, 3, 4. It needs 2 more. But later on, the technical way you want to write it is that it's endo. And you'll learn more of that in maybe OChem 2 or maybe later in OChem 1. But the way you draw it is just like this. 1 up and 1 down. Same with this, 1 up and 1 down. Alright, this carbon here has 2. So how many does it need? Oh, this carbon has 3, look. It's surrounded by this one, and this one. So I just need 1. This carbon. Oh, and then 1 next to it. I need 2 hydrogens. And then finally the carbon in the corner. I already have 2 bonds, so I need 2 more. There you go. And that is how that one's set. So let's look at this structure. Let's count our carbons. 1, 2, 3, 4, 5, 6, 7. Put in our hydrogens. Each carbon that's in the corner is a CH3, which means 3 hydrogens. Now, it did say that this carbon already has its 4, so there's no hydrogens here. A carbon has a double bond attached with another bond, just needs 1. And the other carbon is the same as one previous, and that's it. And this has a lone pair. Okay, so what I want you to see is no matter what structure they throw at you, you see this one's a little funky. This is a bicycle structure. It's a little unfamiliarized to you right now, so it's a little strange. Look at it. Is that no matter what they throw at you, the same rules apply. So this may look a little weird. Doesn't matter. We're still using the same rules. Each end will be a carbon. So 1, 2, 3, 4, 5, 6, 7. Circled our carbons in. And this has 2 bonds, so it just needs 2 more. 2 bonds, 2 more. All these 3 carbons here are the same. So that's why I'm putting 2 hydrogens. The only carbon that's different is this one here in the middle. This carbon has 4 bonds already, so I don't need to add any more hydrogens. On this one, this carbon is the same as this carbon. So I just need 2 hydrogens, and this one is the same. And we have this carbon here with a double bond. And 2 other bonds, no more H's, and we're done with that. So that is pretty much how you figure out where the carbons are and where the hydrogens are, and no matter what structure they throw at you, always use the same rules and you will be good.